In the previous lesson, I explained the relationship between AI and ML. In this lesson, I explained the final two parts of my original definition of ML: predictive insights and decisions. Recall the original definition I gave for ML. We've talked about standard algorithms, which are well-established and repurposable pieces of code used for particular types of use cases, like image categorization. We've talked about how, because ML learns only from examples, data quality and quantity is extremely important. The next part I'll talk about has to do with predictive insights. What is a predictive insight? In our example, we are going to apply our image classification model to new parts that are yet to be manufactured so that it can tell us whether the part is fractured or not. Unlike traditional BI dashboards and data analytics, which describe historical data, predictive analytics is focused on the unknown, whether it's the future, a new product, or a new consumer experience. With predictive analytics, you gain an estimate of the likelihood of something you didn't know before. Earlier in this course, we talked about the fact that many of the analytics done today might be backward-looking, looking at historical trends, for example. By contrast, ML is forward-looking and about predicting the future. Now, let's look at the last part of our definition of ML, which is focused on making repeated decisions. ML works for making repeated decisions, not occasional ones. As you think about applying ML in your business, I want you to remember this part of the definition. It is often where you will get the most business value. That's because many of the benefits of ML, including scalability and efficiency, are only realized when you use it repeatedly. How does this part of our definition apply to our example? Think about it. You need to make decisions repeatedly about which parts you need to remove from your assembly line so you aren't using any bad ones. ML wouldn't be very useful if you only had to classify one part. However, it can be very, very useful if you are classifying parts every minute. Can you think of other examples of repeated decisions? We've been looking at quality control of individual parts on an assembly line. But what about recommending the right product to your customers throughout their exploration of your catalog of parts? Or continuously predicting the moment-to-moment price of commodities? Those are examples of repeated decisions where ML might be a good choice. But what about something like quality control of a space shuttle? Here's a graphic showing the number of shuttle launches per year from 1977 to 1998. There were only a handful, so we probably won't be making that many decisions or have that many examples. That might not be the best application of ML. What about an annual sales forecast? Most businesses do that, but again, we don't do it that frequently. There are also many statistical analysis tools we can use for it. What about trying to model the likelihood that a truck might break down? At first, you might think trucks don't break down that often, so you don't make that many decisions related to them. But what if I told you that each day mechanics decide whether they should inspect vehicles for issues to find if the truck is likely to break down? Then it becomes a frequent decision. And if we have enough examples of breakdowns, we can solve the problem with ML. So as promised, we've reviewed all the key ingredients for a recipe for ML: data, standard algorithms, predictive insights, and repeated decisions. Look for scenarios where these key ingredients come together. Then you can use ML to transform your business. I hope this recipe has already triggered some ideas for you, and you are starting to reimagine what's possible. Back to our example. Let's say that we have built a machine learning model to find bad parts and remove them. Quality control is now pretty inexpensive. So what? The business factor motivating us isn't my business will save money. It's I could add quality control throughout the manufacturing process. Instead of just doing the quality control at the end of my manufacturing line, we can now insert it everywhere and improve overall quality. Take advantage of the ease of creating new models to continue to transform your business. So now you know what ML is, and I hope you've started to come up with some ideas of your own related to ML.